Okay? Relation, connection between two quantities. Give me an example. What Bailey eats and what's stuck in her teeth. There's one example. What's another one? Of course, the one example I gave you yesterday, which really is totally irrelevant, that's the one that sticks in our head, right? Well, just remember, there's only so much room in here. If you fill it with things that don't have any meaning, there won't be anything left for things that do have meaning, right? But, you know, hey, we're all human, right? What else? Some other examples. What are two things that are related? A billion options out there. Ah, good. That was one from yesterday. Yeah. Or not just a computer. We're going to look at a car today. How does a car compare its value with time? Does it go up in value? We'll talk. Maybe. Yes, maybe. We'll talk about that later. Here's a weird one. I don't know why I'm thinking of this, but when you go to war, usually the country, maybe you talk about this in socials, right? Usually the country with the more ammunition usually ends up winning. Okay? Or the better technology when it comes to ammo. Remember when the US went to Iraq? Were you guys even around then? How long ago was that? Oh, I can't remember. Time flies. Iraq has a huge army, okay? But it's all like foot guys with guns. They put them everywhere. And the US was going to go in there. I'm part Italian, okay? They were going to go in there, and Iraq, Saddam Hussein was going, oh, yeah, good luck, okay? I outnumber you by 10 to 1. My army's huge. Well, the US took a plane over there, bombed a few strategic parts, sat back and waited a month. They were all starving to death. They couldn't give them any more supplies. They sent in a couple of guys, and 100 people came raining up. We surrender, feed us. Okay, you know, who's smarter, right? Who won that war? Anyway, that's a relation. Ammunition and success in a war, that's a relation, all right? Hopefully we don't have one again, because there's, you know, it's not really worth it. What are we talking about today? X and Y intercepts. Have you heard this term before? Does it have meaning to you at the moment? Okay, well, hopefully it'll better. Will. Connection between okay, this is a little review from yesterday. I'm trying to, do you know the speed at which I talk is completely related to the amount of coffee I've had? There's a relation. All right. Okay, let's slow her down. A set of ordered pairs. Okay? Ordered like, you know, X, Y, comma. But hey, might be R and S, might be A and B. Okay? Might be me and coffee. All right? Okay? The first component in a set of ordered pairs is the, good, also known as the input. When you were graphing everything yesterday, we gave you a bunch of X's, or we said, hey, make some of your own. You always want to know what's happening around the origin, right? So if they don't give you any, here's your bread and butter. That's what you want to use for X, okay? What's going around, what's happening around the origin? You always want 0. Let's take a couple negatives, couple positive. Let's see what's going around here, okay? If we need more points, then maybe we put a couple more. But that's where you want to start when you're graphing, okay? Those are the inputs. You give the inputs. What are the outputs, okay? The inputs are values of the independent, okay? That's like fixed. If you're talking science, that's what we give you that's fixed. That's the control. How does this vary something else? Okay? If I got a plant and I want to see how it grows by how much water you give it, anyone do this in like grade 2 or 3? Okay? Common science experiment. All right? Bryce doesn't remember. It was like too long ago. Okay? See how much water. We're going to give 2 plants different amounts of water and see how that varies the amount of growth they have, right? Okay? Anyway, second component is the, well, if you got X, there's the Y, also known as the output. And the output, how does Y depend on X? Okay, I put in X, in my equation, what is y? Input, output, independent, dependent, okay? That's the important highlights from yesterday. Here's some graphs. Which ones are we, well, which one are we concerned about in Math 10? The linear graph, the linear relationship, i.e. the line, okay? This is grade 11. This is, are we even doing that in grade 12? I don't even know. We used to do that in grade 11, graph circles, okay? But now we don't. Okay, graph 1 crosses the x-axis at, do we see where that crosses the x-axis? Like right there. Like, what's that coordinate point where it crosses the x-axis? -3. What's the y-coordinate? 0. That's a coordinate. We always want x and y. Graph 2. This is called the parabola. Okay? It crosses the x-axis 2 times. There and there. What are the coordinates of this guy? Looks like -1, -2. And what's the y-coordinate? 0. This guy, 1, 2, 3. And what's the y-coordinate for this x-intercept? 0. That's what these are, right? That's an x-intercept, if we didn't know. Where does it cross the x-axis? That is a definition of an intercept. Okay, a circle. Again, it crosses the x-axis here, -4. And what's the y-coordinate? Does it sound like a broken record here? And it crosses it at 1, 2, 3, +4. And what's the y-coordinate? Yeah. What do all these points have in common? I'm going to say this several times. I want to emphasize, I'm still saying it to some grade 11s, and they still don't get it. Okay? 0, 0, 0, 0, 0. All these points have in common the y-coordinate is 0. Always at the x-intercept, that's here. What's your value of y at the x-intercept? We just answered it, but I want to emphasize it. It's always 0. Okay, we'll say that again in a few minutes. Now, where does it cross the y-axis? What's another word for that? The y-intercept, right? Where does it cross the y-axis? That's the y-intercept. Let's look at this guy. Where does he cross the y-axis? That's the y-axis. He crosses it right there at, what's the coordinate of that point? 0, 5. Okay? If I can, my graph's too big here. Here, this guy, does he cross the y-axis? Yes, he does. That's the y-intercept. What's the coordinates of that point? 0 and 6. And the circle crosses it twice. What's the coordinates of this one? 1, 2, 3, 0 and 4. And where does it also cross? -4. So 0, -4, right? That's the coordinates. What do all these have in common? X, not intercept, X coordinate is 0. Always, 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 I don't care what line we're talking about, where it crosses the y-axis, what's the value of x there? 0. Yeah. Did I say how easy that is to forget? Did I say how many times I'm reminding this to grade 11s who have heard this? I exaggerate not. 40 times I've said that. At the y-intercept, x is 0. Okay? And they'll get a question after all grade 10 stuff. Sure, maybe you get 5 months off, you don't do any math, do all that arty stuff. Then you come back and you get math 11, and they're still going. A question says, the y-intercept is 5, and they go, well, that's not a coordinate point. Yes, it is. What happens at the y-intercept? What's the value of x at the y-intercept? Oh, it's 0. Yeah, that is a coordinate point. Okay? So, is this something we want to try to stick in our noodle? Yes, it is. The x-intercept of a graph is the x-coordinate of the ordered pair where the graph intersects the x-axis. That's what x-intercept means. Where it crosses the x-axis. Here, that's the x-intercept, right? That's where it intercepts the x-axis. Okay? An x-intercept occurs at a point on the graph where the y-coordinate, what does that say? Always. Never fails. Always, always. Okay? Same thing for y-intercept. That's where it intersects the y-axis. What happens at the y-intercept? What's the value of x there? Always. If you don't remember that on your quiz on Tuesday or Wednesday, you won't be able to get a question. You won't be able to get marks. Okay, and that's all you care about, right? It's not knowing this stuff, you just care about the marks, right? Show me the gold. Make mom and dad proud. Okay, how do we do this? If you want to find the x-intercept, hey, what happens at the x-intercept? Y is 0. That's how you do this. What happens at the y-intercept? X is 0. Have you ever heard that before? All right. No, we're up to about 5. Don't exaggerate. Let's make it 6. All right. Here is a linear relationship between x and y. We don't know much about this thing yet, okay? But if I was to ask you, and this will be on your next quiz, and a third of you won't get it, and it'll be on the test, and I'll say it, yeah, another 10 times, and still a quarter of you won't get it, okay? I don't know what it is with this stuff, but how do I find the x-intercept? How do I find the x-intercept? What does this say? What happens at the x-intercept? What's y? 0. So let y be 0 and solve this thing for x. Okay? Let y, let's write this. At the x-intercept, y is 0. So you're going to substitute. What's 3 times 0? 0 is 5x plus 15. Okay? 0 is 5x plus 15. What is x? That's the x-intercept, right? If y is 0, that's our definition of the x-intercept. Where does it cross the x-axis? I need to solve this for x. Little two-step equation. Got to get rid of 5, got to get rid of 15. It's usually easier if you get rid of the 15 first. What's the opposite of plus 15? Minus whatever you do to one side, do to the other side. Okay, what color did I have? Purple? No, I didn't. I had fuchsia. Minus 15 is 5x. 5 times x. What's the opposite of times, Liam? Divide 5 away. Let's go back to red. Okay, what is my x-intercept? How many times 5 going to 15? 3. And it's negative. Okay? To find the x-intercept, what happens at the x-intercept? That's how you do this, guys. Okay? Always, always, always. This thing tells me my x-intercept is minus 3. That picture doesn't look that bad. Let's call it minus 3. Okay? Y-intercept. Same line. I want to know where this line crosses. Okay, the y-axis, is it there? Is it there? Is it there? Is it there? I don't know. How do I find the y-intercept? What happens at the y-intercept? X is 0. Solve this thing for the y-intercept. Okay, let x be 0. So 3y is 5, x is 0, plus 15. Okay, what's 5 times 0? Yeah. So 3y is 15. I got to solve that for y. Got to get rid of the 3. 3 times y, that's what it says. What's the opposite of times by 3, Calvin? Sorry. Divide by 3. That's right, Calvin. Okay? Because 3 divided by 3, it's not nothing, it's 1. Right? How many times does 3 go into 15? The y-intercept, that's what I'm doing here, is 5. How many points do you need to graph a line? I don't need 3? You need 4? What? Are you golfing? Do you shoot a ball like way over here? 4? Okay. Yeah, you just need 2 points, right? What does this line look like? Okay, I'm lost. All right. Calvin, how many points do we need to graph a line? 2. If we have 2 points, we can make a line because it goes straight, right? Okay. Okay, I don't know what you guys are doing, but this is the x-intercept. That is coordinates minus 3, 0. Or you just go minus 3. It's on the x-axis. This is the y-intercept. That's where it crosses the y-axis. Its value is 5. There's 2 points. Can we make a line, Alicia? Yeah. There it is. I graphed that line. Only need 2 dots. Did you say dot or point? Points. Coordinate points. 4 pieces of information in 2 coordinate points. That's what she's getting at. Okay. Yeah. All right. I'll go with that. All right. Okay. Anyway, moving on. I'm not going to do this because you know what? That's like so grade 11. Yeah. Squared makes it go curvy. So let's not even worry about that. Okay. I didn't teach it. I passed over it. I don't know. They're smarter in Alberta. That's where they do that. No, they're not. Okay. I need to make this a bit smaller so I can see more of it. Okay. Lisa purchases a new car. I don't know. You guys, let's see. I like to give you time to work on your assignment. Okay, so it's 20 grand. That's a, pretty cheap car. How many new cars will appreciate in value over time? How many new cars today you will buy, new, will go up in value over time, do you think? You're probably right. Maybe that one-off Ferrari that was like limited edition, they only made 50 of them. It was 1.1 million. Some billionaire is going to buy it, sit on it for 6 months, talk to his other billionaire buddy, and he's going to go, I don't have one of those in my garage. Tell you what, I'll give you 1.5 million for it. Okay. Now make it 2 million. Okay, done. All right. Yeah, that's an exception, but yeah, 99.9% of all new cars depreciate. They go down in value. I'll go so far as to say, as soon as you don't even drive it out of the dealership lot. You don't even put the key in the ignition. As soon as you sign the paperwork, you lost $2,000. Maybe even $3,000. If it's a BMW or a Porsche, you probably lost 10 grand. Before you even turn it on, it depreciated because now it's used. Right? It's pre-owned. Who's going to want to buy your BMW for $72,000 when it's used? I don't care if it's got 2 kilometers on it, when I can get a new one for 75. Like, why would you be selling that? What's wrong with it? Too many questions. And besides, I can walk into the dealership and they'll finance the whole thing for me. I don't have to go to my bank and get a loan, okay? You lost $5,000 or $6,000 just by buying a new vehicle. The first day, that's depreciation. Yeah. Okay, anyway, here is a relationship between the value of a car and time. Think about this. This is the value. It starts off at 20 grand. That's the day you buy it. We're going to subtract this amount. T is years. Okay? Every year, according to this, it loses $1,250. I'm willing to say you lost that the first day. Okay? But in reality, we can't give you a practical question because it's not going to make a linear relationship. Okay? This is what we got to go with. All right. Complete the table of values. If the input, this is T, right? The value of the car depends on how old it is. Doesn't really make sense to say it the other way around. So the independent, the input, what's on our x-axis? What's always on the x-axis? Time. Okay, time is always independent, 99.9% of the time. Okay? If T is 0, you plug it in. You go 20,000 minus 1250 times 0. No time has expired, i.e. that's the day I bought it. What's it worth? Right? 20,000. I subtract nothing. If I subtract 1250 times 2, or $2,500, then now this is saying it's worth $17,500 after 2 years. Holding its value pretty good. Are there any Ford fans in here? Okay, I won't say it. So it's not a Ford. Sorry. Huh? No, if it's a Ford, it'd be worth like $8 grand already. Okay. No, I'm kidding. I'm kidding. All right. After. Good thing I didn't hear it then. 4 years. What's 4 times 1250? Well, what's 2 times 1250? That's 2,500. This is 5,000. 20 grand minus 5 grand, that's 15,000 after 4 years. Okay, I don't care what vehicle it is, nothing holds its value this well. Okay? After 4 years, you're lucky if it's worth less than half of what you paid for it. Okay? Even Hondas and Toyotas. Those are the ones who hold their value the best. Right? Get most resale.
She said after 2 years it's worth about $10,000.
Hey, you know what? The way Emily's probably going to drive, I believe it. All right, dents on every corner. Don't change the oil. Yeah. All right. That too. After 6 years, it's worth $12,500. Okay? We want to plot this thing. Where time is 0, this thing's worth $20,000. Okay? There's the point, right there. After 2 years, 1, 2, it's worth $17,500. After 4 years, 1, 2, 3, 4, it's 15. After 6 years, 1, 2, 3, 4, 5, 6, it's worth $12,500. Like I says, that's not really practical, but we need to make it a linear relationship. Does it look like a line starting to form here? Okay, why don't I need to plot many more points? Because it's going to be consistent, right? Can I use my graph to find out what it would be worth, say, at 7 years, 9 years, 10 years? Yeah. Is this continuous data? Does it? Yeah, you can divide. How much does it depreciate in 1 year? $1,250. I could work that down to the day. I could work that down to the hour, right? It's continuous. So if we're going to join this, because we need to make it work and I don't have a ruler, make sure it goes through this point, 16. Okay? That makes a perfect straight line. And I've even tried this with a ruler on my tablet, and because somehow the projector distorts it, I can never get it to work. Okay? That's where it would go through if this was on paper. Perfect graph, and I did it with a ruler. Okay? People who are good at graphing will look at that and understand what it means, right? This is the value. As time goes on, the value gets lower and lower and lower. Yep.
It loses 14 cents.
Every hour I lose 14 cents. Eh? And that's if I don't drive it. Yeah. Okay, what does this mean, the ordered pair 0, 20,000? That's when I bought the car. New price, right? 20,000. Brand new car. Time is 0. That's before I put my signature on the dotted line. Sold my life away. By the way, if you got a loan for this, by the time you paid it off, it'd probably cost you about $30,000 with interest. Okay? After 5 years, you're still paying off this car, and it's worth less than what you have in equity. Anyway, let's not talk about that. Estimate the t-intercept. Huh? We talked about X-Intercept. We talked about Y-Intercept. Is there any X and Y here? No. It's T and V. Right? There's no X and Y. It's T's and V's. Where does this cross the T axis? What does that mean? What does that represent here? It has meaning. It's not just an x-axis, a t-axis. Liam? When the car has a value of 0, according to this, is 16 years. Okay? It's landfill.
So 17 years, yeah, we'll start paying them again for it? Or
Let's not go there. You're going off in like the 4th dimension. Okay? No, it doesn't really work like that. It's landfill. And actually, there's not many cars on the road over 10 years old. Most of them get to the landfill before even 16 years. Okay? This thing's worthless at 0, according to this graph. Now, in practical terms, what really happens? It goes like this. At some point, you know, it kind of levels off. If it's 14 years old, 16 years old, what's the difference? Maybe it's worth $1,000 here. It's probably still worth $1,000 next year. Hey, maybe you made some more repairs, put new tires on it, put new brakes on it. Maybe now it would actually go up. Okay? But like I say, where this is Math 10, we need a linear relationship. Okay? Could I use the graph to estimate anything? What's it worth after 10 years? Right there. What does this say? Looks like about $7,500, right? Could I use the equation also? Okay, well, how would I do that? Well, there's my equation. 20,000 minus 1250t. Minus 1250. If t is 10 years, what's 20,000 minus 12,500? Hey, look at that. Same thing. Okay? So you can use the equation, you can use the graph, but if it's offside, if it's way out of the graph, you can't use the graph, right? Okay? Calvin's got a strange question. Well, what is it worth at 20 years? It's worth negative $3,000. That doesn't make any sense, right? Note, we just have the first quadrant here. Negatives don't make any sense. That's why I don't have the 4th, the 3rd, or the 2nd quadrant, okay? Just the positive stuff. All right? So half of the purchase price, how long does it take until I've lost half the value of this car? When is it worth $10,000? According to this, 5, 6, 7, 8 years. Could I also use the formula? Yes, I could. Okay? In reality, it's probably closer to about 5 years. You buy a $50,000 SUV, 4 or 5 years later, you're lucky if it's worth 25 grand. Okay? cars are not good investments, but we all kind of need one, right? Okay. Originally it cost $20,000. It depreciates by $12.50 each year. That's why they got $12.50 in the equation. It has no value after 16 years. Okay? It's landfill. If this stuff is outside of the graph, just two little words, okay? Intermediate values is called interpolation. And if we're going to extend our graph, like go beyond where it's supposed to, like say we went down in the negatives where it doesn't make any sense, that's called extrapolation, okay? Okay, 1, 2, just A to D for both, 3, A to C, and is that a 6 or a B? That's a 6. 4 and 6.
No, I think we should definitely just do 4.
I don't even know if that makes sense.
Yeah, just these parts of 4.
No, all of 4. Good stuff.